My name is Dr. Pamela Gay, and I'm your host this week for CosmoQuest's Science Hour. And this week it's actually going to be the Science Education Hour. This weekend is International Observe the Moon Night, and we hope that all of you who are out there are going to go out, look up, and enjoy the first quarter moon, and help us celebrate the fact that the moon is something that everyone on the earth shares, and all of us come from cultures that in one way or another are tied to the moon. Even the modern American culture, the Apollo missions are something that's very much even an inspiration to people today who weren't alive, and nowadays most Americans weren't alive when we had humans walking on the moon. There's a lot of science engaged, and most people aren't aware of just how many new discoveries we're making every month about the moon. So we ask you to come celebrate the culture, celebrate the science, and to look up and look onto the moon through moon mappers if you have a chance. With me to discuss this topic are two of my colleagues at Southern Illinois University, Edwardsville. We have on the far left of the screen, Georgia Bracey, and in the middle, Nicole Gugliucci. And they are the formal education and informal education leads for the CosmoQuest project that we're working on. And they're going to talk to you about a new project we have that we're calling TerraLuna. So, Georgia, do you want to start, perhaps?
Okay, sure. If you're in formal education as a teacher, or whether or not you're just doing scouts or a homeschooler, any kind of education that you do, you want to bring science and real authentic science to your students, and that is what our unit helps you do. We have a unit that goes with moon mappers, the citizen science project, where you look at the surface of the moon and you map craters and you find all kinds of other interesting things on the surface. We have a unit that is really good for 7th through 9th grade students, but you can, scale it down a little bit, make it a little more difficult for, upper students. So it can be, up for high school and lower. It just kind of depends on, what kind of students you have. So it's pretty flexible, and most teachers are very flexible. So even though it is focused for middle school, upper middle school, you can work with it and kind of take it almost any way that you need to, because we have lots of resources, lots of connections that can be made to all kinds of places in this unit. So you do want to bring authentic science into your classroom if you're a teacher, or just to your students, to your children, to your scouts.
Now, what does authentic science mean? Because we have lots of people who aren't science education people out listening to this, and when you say something like authentic science, it makes you think, well, of course you don't want to do inauthentic science, because isn't that called paranormal and ghosts and woo? So what do you actually mean when you say authentic science?
When I say authentic science, I think of access to data that scientists are actually using right now. So it's not something that you've just made up for your students to do, which does happen a lot, and which is fine. You can get a lot of value out of just creating a data set or some activities that would get your students, some nice exposure to the scientific process. But what's great about working with citizen science, and especially a project like Moon Mappers, is that not only are you getting a glimpse into the scientific process and the different ways of thinking that science involves, but you really are helping scientists analyze data. So you have access through something like Moon Mappers to data that real scientists are looking at. And then as you go through the tasks of the citizen science activity with your students or your kids, they are actually doing science. The scientists take their data, they take their analysis of the data, and then they use it in their research. So it's authentic in the sense that it's what real scientists are working with now, and you're a part of the process, and your students are a part of the process. And that is very powerful, making it really real. They know that what they're doing is going off, a scientist is looking at it, and it's going into their research and their analysis. So that's a very exciting thing for students.
Now one of the things that we've been working on is trying to figure out what do people already know and what do they really struggle with? And one of the things that I think took all of us by surprise is if you hand a human being, doesn't matter what age they are, it doesn't matter what degree they have, if you hand a group of people a piece of paper, or even worse, if you hand them a computer with a web browser and you say, mark the craters on this image, they're going to do all sorts of crazy things. They're either going to mark the centers, they're going to draw a big circle around the crater. And so when we say things to our students and to one another like, well, let's mark craters, that is a strangely ambiguous statement that we didn't understand was going to be ambiguous. And we've also been learning that people don't really understand what are craters, why are craters important, and with this activity that you have been developing, both of you, for the past couple of months, it's really neat because it starts off from the, well, let's go make some craters, to let's understand how the energy released during different types of impacts creates different size craters, to let's do this on paper and learn what it means to actually mark a crater, to finally let's get online. So you're really building up this neat experience for whomever we're working with. And Georgia and I have gotten covered, mostly Georgia, covered in cocoa and flour doing activities with kids at the U.S. Science and Engineering Festival. Nicole has sacrificed herself at a variety of places as well. And so this is something that you can do this weekend for International Observe the Moon Night, hint, 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 or you can do it with your Girl Scout group, your Boy Scout group, just about anything. And that is the most colorful and awesome image I have seen so far.
So that's an action shot of this activity that Pamela's talking about, where you can make a crater, which I think Georgia can probably explain a little better than I can. This is from when I was in Virginia with the Dark Skies Bright Kids group. This was one of their most favorite activities because you get to make a huge mess while learning about geology and science.
Okay, so let's unpack this a bit. It's a tarp, it's a bowl, it's flour and cocoa, it's objects flying from the sky. So what are we teaching? How does this get done? Let's explain it to people who want to inflict craters on others and who doesn't.
Yeah, it's lots of fun. And if you use flour and cocoa, it really smells wonderful.
It does.
So that's just a bonus. This is obviously a really good concrete hands-on activity for kids, and what it shows them is how craters are formed. So it's basically the process of an impactor, hitting a surface at high velocity, and then here's what happens. And not only can they see the crater formed, but they can see the ejecta come out. And they can see all kinds of, different colors if you use different types of materials. So they can begin to see all of the exciting things that just a crater itself shows scientists. So it's not only the process, the fun of making a crater, but, they get to see right there all the different things you can learn from just, what you might think at first, oh, just an ordinary crater. So it really is a nice way to get the students, involved right away with a great, fun, interactive activity. And it's just, each crater is different every time. Yep, and you can talk about the difference that the size of the impactor makes. So there we have a couple of different impactors. You can get really creative. Almost anything works. They get the idea right away that, boy, if you have a bigger impactor, you're going to really make something incredibly impressive. But they also come up with pretty quickly the idea that the speed of the impact might make a difference, the angle of the impact might make a difference, the types of material that it hits might make a difference in what they see. So, real quick they can make those connections to the kinds of science that goes on when scientists are looking at craters.
So to explain what all you're looking at, you take a bowl and you either go outside or you spread a tarp or a towel or you don't care about the floor you're on and you put into the bowl a inch or so level of just plain white flour. You then dust on top of this, and one of those coffee sugar or cinnamon or cocoa shakers is excellent for this. You take some cocoa, you put a thin layer of cocoa across the top, and then you drop things into it, and you end up with small sticky children who smell like brownies. But one of the nice things that gets shown with this is if you take two objects that are the same size, for instance, two gumballs is one thing that we use. Two gumballs, and you drop them from the same height, they'll form very similar craters that are roughly the same size, the same spray of material around them. Now, if you take those two same mass objects and drop them from very different heights, the one is going to end up distributing material into a larger radius around it. And this is because the energy that it has is able to displace more flour when it spreads that energy into the material that it's impacting on, which is the same idea of we can look at craters and go, wow, that crater had so much more crater melt, it has such a larger radius, therefore more energy went into it.
So this is a great activity because you can see how all the different concepts you can talk about just from this one thing. You can keep it simple so the lower grades can get something out of it, just having fun, slamming things into the flour and looking at what gets formed, all the way up to talking about the energy and those more complex topics that, you know, in high school level, they could still get a lot out of doing this activity, and they love to do it, even when they're in high school.
And there's a great XKCD that mentions, so many of us in our lives find ourselves saying to people, wow, how did you not know that? But when you think through all the different things that people basically have to learn before they become adults, there's always someone who's not yet an adult learning one of those common sense things, and craters are one of those things that I keep thinking of as common sense. Well, what's a crater? But everyone has to learn at some point in their life what a crater is. And prior to learning this demo, I, being someone who's not generally near small children, was encouraging small children to go throw rocks in sandboxes to learn how craters are formed. And I did this for about 6 hours before Fraser, who was manning a booth with me, said, you realize you're encouraging small children to throw rocks. So this is a way to teach small children how to make craters in a way that is entirely safe and smells like a candy store, also to be encouraged.
Yes, at one of our conferences, one little boy did this for like 10 minutes with cocoa as one of the layers, and as his mom led him away, she said, wow, you smell like a brownie. Yeah. And it's so true. It just really, it's going to make you hungry if you do that, but it's great.
And I kept eating. We were using that day, we were using
gumdrops.
We were using gumdrops, and I kept eating our props. So apparently this is not a demo that should be done near me when I'm hungry. But the stuff that we do to try and teach people about craters, it isn't all about dropping objects and measuring the diameters of craters. It's also trying to understand why craters matter. And I know this is something that you've been working on a lot, Nicole, with trying to explain to people aging. So do you want to
Sure.
Go for it.
Yeah. So we are putting together an activity that explores how counting craters gives you an idea of the relative age of a surface. And so you may know that, okay, the moon has lots of craters on it, and the Earth does not seem to have a lot of craters on it. And one of the main differences is that the Earth's surface is always being replenished and refreshed. It's a very young surface compared to the surface of the moon. Now, if you look at different areas on the surface of the moon, you can look at different, whether or not there are more or less craters, and use that as a way of telling the relative age. It doesn't tell you the exact numerical age of the surface, but it gives you an idea of what's older and what's younger. And so if I can screen share this window, so we've taken a large section of the moon and broken it up into smaller pieces. And when you print them all out very large, you get this. I'm talking with my hands, which is useless right now. But you get this very large poster-sized version of this map of the moon. And what you can do is we have each of these images separated so that you can give these images out to your students or to your kids or to your adults that you want to show moon stuff to. And what we have to do is you have them mark the craters. Now, okay, like Pamela was saying, mark the crater is kind of an ambiguous term, and I'm going to hope this shows up on the screen. But when you give them these pieces of paper, now this is totally not going to show up on video, but
It totally shows up.
Oh,
You're
it shows
good.
up?
Good,
Okay.
yeah.
It's frozen for me. Okay, there we go.
That's very good.
You get usually a silver Sharpie works really well on the printed paper, and you have them draw a circle around the rim of the crater. And we have kind of a sly secondary point to this, is that this helps you with if going into the citizen science moon mappers stuff. But just for the analog version, you have them mark the craters with a Sharpie and count them, and then unfortunately what I don't have here is you get some kind of colored cellophane or colored plastic to match up with how many craters there are on each small picture. When you put the map back together, what you would get is a colored version of this right here, and like a large classroom version, and then you'd have all colors on them, giving you an idea of the distribution of what's an older surface. Say your older surface is blue to green to yellow to orange, and orange may be the younger surface, and you can actually see this gradient of age across the area that we've chosen.
And
So
and this is and this is
say
what,
real quick that there are files that you can download with some samples of this right now if you want. If you go to the CosmoQuest blog, you can download a bunch of sort of samples of what we're working on, and in there is a sample of what Nicole just showed you with some colors on it, and that'll kind of give you an idea of what we're aiming for with this.
and one of the things that I've loved watching them do this is I do a lot of informal education research, but I work with adults, and there's so much more thought and care that has to go into things that are designed for K through 12, because at least in the United States we have a set of standards you have to teach for, and then in Australia they have a set of the standards they have to teach for. In Europe they have a set of standards they have to teach for. And we've been working to make sure that what we do covers the type of content that is universal. And we're working one by one to plug away on listing out for educators what standards we're teaching. So on the U.S. side, this sort of thing teaches the evolution of the solar system, the Earth-Moon system, and a lot of other things. And it brings home our place in space. And it does it in a way that teaches a lot of secondary skills, from math to plotting to just how do scientists do the things they do. And oh wait, I can do what scientists do. So it also provides ownership to the students in terms of what's possible through science. And there's also some neat side things in it, because when I mention Earth versus Moon, there's a reason. So, Georgie, do you want to talk about Ellen's Earth-Moon?
Sure. I can tell you actually a little bit more about the way the unit's designed. Each lesson is built on the 5E curriculum design. For if you're a teacher, you might be familiar with that. And when it starts, the first E is to engage the students. And so one of the first activities we have to kind of get them engaged and interested and thinking is we have a set of pictures, some from the moon and some from the Earth. And so they're surface features from each place, and they're in black and white.
Nicole beat me to it.
And this should be in the sample files from the blog too, so you can get an idea. And what we do is we break the kids up into groups, and each group gets, I believe, 5 Earth pictures and 5 moon pictures. And we, of course, don't tell them which is which. And so their first task is to sort of collaborate in their group, take a look at the pictures, and group the pictures according to moon or Earth, which one is which. And they have to come up with good reasons, because part of what we're emphasizing is your thinking. You know, don't just do it, but be able to communicate to each other a reasonable way, a process that you came to your decision. So as they're sorting these out, they also have to think about, you know, why are they sorting them out? Why do they think, you know, number 1 is the moon and 2 is the Earth, or vice versa? And so this becomes their first glimpse at comparing the two bodies. So they can see, you know, when we bring them back together as a class, you know, there's a little argument, there's a little discussion, and we start to, you know, sort of tease out, the ideas that, the Earth has craters, the Moon has craters, the Earth has little like river type features on it, and so does the Moon, which a lot of kids maybe wouldn't have thought about before. There's the highlands, the lowlands, the Maria, and then there's similar features that you can compare on the Earth. And then, that leads into a discussion too of, well, we see lots of craters on the Moon. Where are they on the Earth, and why do we not see as many? So this is just a neat sort of quick sorting and classifying activity, which, kids love to do. We're really good at, sorting things out.
And this is a great thing to do when you're doing demos with the public. So if you're, just to hit on it again, doing an International Observe the Moon Night activity this weekend, this is the type of thing where you can take the images we have, laminate them, cut them out, probably not in that order, and have them out there for people to flip through and make their guesses. And so this is a great way that you can get people engaged while they're waiting in line for telescopes or otherwise milling around. There's always that spouse or child that resents being dragged there. Well, this is a way to hopefully get them engaged in actually being interested in the event.
Right, so this is one of our little engaging activities. And again, one of the files that you can download off the blog is an overview, an outline of the full 2 weeks of the unit, because it can cover 2 weeks. But again, you could certainly, pick and choose things, sort of tailor it to whatever kind of situation or environment you have as you're teaching. Mm-hmm. So it's, there's a lot of good stuff there, all the way from just sort of introductory activities to an introduction to citizen science and the Moon Mappers project, and then links and resources to go beyond if you want to and if your kids are able to. So there's a lot of great things in there. We hope that you'll take a look at them and also give us some feedback, because this is a pilot. Well, we are piloting it. It's just a draft at this point. So we are looking for feedback, and we've got a whole wonderful list of teachers that are going to try this out in their classrooms. Some already have. We had one focus group with teachers over the summer. So we are definitely looking for a lot of people to try this out and let us know what you think.
And we have to give props to Rosa Doran with the Galileo Teacher Training Program over in Portugal. She's actually been working with us to get these things integrated into the Galileo Teacher Training Program, and she's taking our lunar crater counting activity and dropping it into Salsa J so that people can do things either on paper, which we deal with a lot of schools that don't really have a lot of computers, so we think paper, and she's also thinking high-tech classroom and helping us find ways to get people using the technology as well as just learning the concepts.
Right.
And I've used some of these activities, like I said, in an after-school astronomy club, so any kind of informal education setting, again, where you are responsible for cleaning up after yourselves after you make a giant mess is always good. But yeah, with informal groups or with homeschool groups, all these activities are really popular.
And just to remind people who are tuning in late, this is the CosmoQuest Science Hour. I am Dr. Pamela Gay, and I'm hosting this episode. Emily Lakdawala of the Planetary Society, she and I alternate weeks. She'll be here next week, probably talking about something new and awesome from planetary science. This week we're discussing the TerraLuna educational program that was put together by CosmoQuest, and trying to give you ideas on how you can engage people in learning and doing lunar science this weekend with International Observe the Moon Night. With me are Nicole Gugliucci and Georgia Bracey, who are the informal and formal education leads for the CosmoQuest community.
I should point out, I also put a link to Georgia's blog post in the comments on the Google Plus page where this is originally posted. I can't seem to put links in YouTube comments.
Yeah,
so
they don't let you.
Go on Google Plus to see it.
So do we have any questions coming in from the community? I have to admit Nicole is the one who has the comments open this time because I was having computer fail.
Don't have any yet. We have a hi from Joe.
Hi, Joe. So if anyone would like to ask us any questions, find out any more information, you can get us comments either through the YouTube comment feed, through the Google Plus comment feed, or by tweeting us at #ScienceHour or #ScienceHour. It depends on what culture you're from, what you want to call that. So the International Observe the Moon Night, for those of you who don't know what it is that we're talking about, this is a project that originated in 2010 as a way to try and capture the energy that got built up through the International Year of Astronomy in 2009 and focus it for one day each fall on fall Northern Hemisphere, spring Southern Hemisphere, focus it sometime around equinox on the moon as a shared discussion point globally. In the March equinox series or time of the year, we have Global Astronomy Month each year, and so first half of the year we get a astronomy celebration. Second half of the year we get one night for the moon, and we're going to take advantage of it. This is something that's been head up by Brooke Shue at Goddard, NASA Goddard out on the East Coast here in the United States, but this is an international event, and if you go to observethemoonnight.org, you can register your own local events, take a look at the map to see where all you can get involved in your community if you don't want to host your own event. And we're going to actually be doing a whole bunch of different things at CosmoQuest to try and get you involved through the internet, because we know some of you don't like to leave your keyboards. I'm one of them, so you're my people. So we're going to, well, it's true, Nicole.
It's funny. No, I get it. I'm the same way. Yeah. We just don't have basements. Well, maybe you have a basement. Continue.
So you can tell we enjoy working together.
Sometimes we get things done.
Yes, as long as we get things done.
Sometimes.
So for International Observe the Moon Night, Scott Lewis, who is just our awesome Google Hangout producer for the virtual star parties, he's working on organizing astronomers spanning the globe. We're going to have people in Turkey, Australia. He listed off a whole bunch of countries. Those are the only two that stayed in my head. Indonesia, I believe. A whole bunch of different countries are going to be involved. And we're going to do 3 different star parties. One kicking things off in Indonesia, Friday night U.S. time, Saturday morning in Europe, and then Saturday afternoon when the moon is up for Indonesia and Australia. We'll be doing another one Saturday morning North America time, evening Europe to celebrate the moon being over Europe, and then we're going to be doing a third one celebrating here in North America. So as the planet rotates, we're going to bring you views from around the world. We should be getting all of the exact times up tonight, as you might imagine, trying to organize all of these different volunteers. This is purely a volunteer effort. Trying to organize all of these different volunteers is a bit of a tactical nightmare. But we're really enjoying it. And if you want to be involved as one of our telescope operators, drop us an email at getinvolved@cosmoquest.org. And I know Nicole and I are going to be 2 of the hosts taking turns as the world rotates and I get on a plane to go to Madrid.
I'm going to be in Philly, so I may show up at the Franklin Institute because it looks like they're doing some fun activities there, including making craters, which sounds familiar. So I get to make a mess in someone else's place.
Never craters. Yes.
I'm excited. We got a question from Tony Richards. Is there a website for more details around the activities and events you're talking about? The 2 main ones would be observethemoonnight.org for the event that's happening Saturday, and then CosmoQuest.org has links to all of our education stuff. CosmoQuest.org/blog will get you to the blog where we currently have the TerraLuna stuff posted. We're TerraLuna, Earth, Moon.
You can also email. You can email educate@cosmoquest.org. Is that right?
Yes.
Right.
I think so.
If you just want to do an email and ask for more information or for copies of the files.
And we also have a question from David Gibson who says, where do the impactors go on the real moon? Because in the picture I had the bowl with the baseball still in it. And that's a great question.
That's a great question. That's
that's fabulous.
Part.
So usually they fragment into a million little tiny pieces. Here on Earth, occasionally we're able to find what's left over from the impact at the bottom, but you'll get like giant crater from impactor. But the reality is, most of the time, the impact releases so much energy that everything that was the impactor ends up becoming the material that gets sprayed everywhere. It's the type of energy that liquefies rock. So when we drop things, it just goes thud.
Yes.
Now, if you drop it enough times, you can actually heat up the surface of your desk by bouncing a bouncy ball on it, and you'll heat up the bouncy ball by bouncing it enough times because of the energy that's lost to the inelastic part of that collision that gets turned into heat. Now, if you were able to hurl that bouncy ball with sufficient energy that it heated to its melting point upon hitting the surface of your desk, you'd destroy your desk and model what happens on the moon fairly accurately.
Yeah, that's where the activity is good for giving you a sense of what a crater is in the first place, but every model like that has inaccuracies. There's something that we can't accurately reproduce, or else we'd actually be smashing things to the planet making a crater, which would be awesome, but we can't do that. So that's one way in which it's not exact, and so that's a great point to bring up when you're doing this activity as well.
But that's okay. That's a good point to talk about with students and kids, because they do ask that question, and then they can use their imagination as you describe to them, what really does happen to the impactor. But especially, in a classroom maybe, but really with any kids, you can talk about, why we use models and, the good and the bad of models. Because that's also, a scientific idea that students need to think about. There's no perfect model. And, you can point to all kinds of textbook diagrams. I mean, there's all kinds of, unfortunately, probably great examples of less than perfect models and diagrams out there. And that's a good thing for them to be aware of. Makes them think a little bit and, be a little more critical, when they look at pictures and diagrams.
And one of the neat things about the fact that we have returned to using space capsules instead of space planes is space capsules and meteorites aren't that different. It's all about the angle of descent that allows a spacecraft to decelerate to safe velocities where they don't heat up to the point of melting and disintegration, whereas a rock coming through the atmosphere generally doesn't have a controlled descent, and therefore it heats up a whole lot more, heats up the atmosphere around it a whole lot more, fragments, and then just hits with large velocity since it isn't helped by parachutes. So there's lots of different concepts that you can unpack and use to get to all sorts of neat conversations within your classroom.
Exactly.
We also have a question from Bryce Gregg. How difficult are you finding it to get great programs like this into schools?
It's actually much easier in other countries, and that's something that disturbs me to no end. One of the problems that we have that Georgia can probably discuss much more effectively than I can, because prior to getting, she's currently working on a PhD in education, has a master's in physics, and is formerly a school teacher. So she's kind of the one with all the expertise here. But as many of you know, we now have a lot of standardized testing here in the United States, and one of the results of standardized testing is teachers don't always have time to bring interesting programs into the classroom unless they can see exactly how it teaches what's going to be on the test. And Georgia can really speak to this better.
Right. Time is always the issue with teachers. It's all about time. So, but the good thing is with an activity like these, a unit like this, is it really addresses a whole bunch of different standards. And if you're, you have to address the standards as a teacher. And we aligned these, they are aligned with the older standards that are currently out there in the United States, but in the fall, and probably actually in early next year, we'll have a set of new science standards, the next generation science standards. They're currently, being looked at and out for public comment and going through their little hoops that they need to go through before they actually become public. But probably most schools will be working with those. So you have to address those standards, and if you have an activity that's integrated like this and that can go in a lot of different directions and address math, address different science concepts, then that's something that teachers can use and something that's really adaptable. This is sort of it's tailored to go with the Moon Mappers Citizen Science activity, which of course is on the internet, but that can be tough still for some teachers in classrooms. So even if you had trouble doing that, you can still use most of this unit and talk about science and the scientific process and what real scientists do. And even if you can only get your students maybe into a computer lab, every now and then, you can still do a little bit. There's a wide range of internet access and technology out there in the schools, especially in the United States. It's really got a wide range. So some schools are very well set up and would find this really easy to do, and others are still struggling. So it's a real challenge.
And Nicole and I are traveling as many places as we can this fall, and then George is going to be joining us to travel as well in the spring to take these programs out to conferences and training sessions all around the United States. So if you follow us at meetup.com, look at our calendar on CosmoQuest, follow our blog. We'll be working to try and keep everyone up to date with where you can find us in the real world and help get hooked up with all of these resources.
Stalk us around the planet.
Yes, we provide you the ability to stalk it.
I should point out from the informal side, the astronomy after school club, there's surprisingly huge demand for something like that. If you have a group of dedicated volunteers that are organized and or flexible, and you get a little bit of press coverage like we did in Charlottesville, and we were getting all kinds of we had to put up an application form on the website for schools to come in and say, hey, we want your program, and we could only do one or two a semester. So if you have a group of people that want to bring this into the schools as an after-school activity, there seems to be a real thirst for that, because you have a lot of students in school till their parents get off work anyway. Here's an extra activity for them to do.
Yeah, that's a great idea, and something like this is also really good for that student that just needs more, maybe needs an independent project, is showing a lot more interest than maybe the rest, or can just work independently and wants to go further. So this would be a great sort of independent activity for
I was so that kid
students or any student who has an interest. Set them out there with moon mappers and let them go, and it's great for that.
I was so that kid. They would give me like extra book reports to do.
It was
great, because I was
Nicole, you do one more.
So what's
this
great
is better than a book report.
is it's not as much busy work, and there's so much that you can get people involved in on both the doing book research. So for instance, how is it that when we say this crater is this many billion years old, million or billion, not both, on the moon, where do those numbers come from? Why can we say that about the moon and not Mars? Why is a Mars sample return so important to being able to prove that our theories that you can use crater dating all across the solar system is valid? In terms of, you see lots of craters here, that corresponds to the same period of lots of craters over on this object over here. So there's lots of stuff that you can do in book research to try and understand. Then there's actual research you can do by working to try and understand how different geological features are interrelated, how you find this thing next to this thing, where you can partner with scientists on real problems. And there are additional problems that just need extra eyes that we can help you find the scientist that may not need the thousands of eyes on CosmoQuest, but might just need 5 or 10 pairs of eyes of your classroom group.
Yeah, it's a great way to introduce students, like I said, into what I call authentic science, but the real world of science, and you may really spark an interest in them, and just the fact that what they're doing is real and making a difference out there is really motivating and can make a big difference.
They Might Be Giant song called Science is Real. That just popped into my head. But we have one more question comment from Howard McCulsey. He said his astronomy club recently put a telescope in the local library, and it is reserved 26 weeks into the future. Has anyone tried to put a program like this, put it in a local library for people, or school library?
Oh, wow.
That's a really awesome idea, and we have to admit we're young, we're a very small team, and so we're always looking for volunteers with ideas, and we'll help facilitate you with these new ideas. It's just we can't come up with all the cool ideas on our own. So tell us what you think would work, and if we can find the volunteers, or if you're that volunteer, we will help. Our goal is to get as many people learning and doing science as we possibly can.
Cool.
So are there any last questions as we start to close this hour?
And
any closing thoughts as well?
While I'm looking at comments, do you want to go, Georgia?
I would say, again, just that we could use some feedback on these. I would take this. Don't feel it's a 2-week unit, but definitely don't feel like you have to do 2 weeks, because, as I said, time is always an issue. So don't be thrown off by that, and don't be thrown off by the fact that it's designed for formal education to be used in the classroom. But you can take bits and pieces of it, like the activities we've talked about, and you can use them in the informal world too, out at the after-school clubs like Nicole was talking about, or a Saturday morning somewhere. So what we know, there's all kinds of situations out there. There's all kinds of schools. There's all kinds of groups that are interested in this and want to do some science. So, this really has a little bit for all of those situations. And we would love your feedback, and we'd also love to know, what kind of situation you're using this in. Are you a high school teacher? Are you middle school? Are you a scout leader? Do you have an after-school club, or a Saturday morning science, couple of hours with kids on the weekend? Let us know, how it's working for you.
Nicole?
I think we've been talking also about doing, so as we did a kind of a teacher professional development workshop here in-house, we've been talking about possibly doing one online. So if you're interested, think about that, because we'll be actually doing them as a Google Hangout so that you can get the materials together and work with the stuff yourself, and go through that material. Yeah, that's what I got.
So I guess the take-home message is, science education isn't always what we want, but sometimes we can make it what we want. And so we're working to provide you the materials that you can use as a teacher, that you can take to your school as a parent, that you can inflict on others that come too close while doing guerrilla citizen science, guerrilla astronomy. And our goal is to, well, I guess, make it fun and make it smell like chocolate, at least with today's projects.
That is a bonus. The other thing too, we haven't talked much about CosmoQuest in general, but the other thing, that teachers need, and that's very helpful, is a support group, a community, a team. And we have forums. We'll be making them a little more tailored, putting some spots for educators and people who are trying this unit out. So we're hoping that we can link everybody who's working with this particular unit and others that will come along later, so that you have a place, a group, somewhere where other people are trying these activities too, and you have a question and you just want to throw it out there, or complain about why this didn't work, or why your computers didn't work one day. Whatever you need to do, that's also really important for teachers, for anybody who's trying out something like this. So CosmoQuest is working to have that be a feature of all of this too.
So tell us how to make science education more possible in your corner of the universe, and we will work to make it happen. And thank you for joining us. This has been the CosmoQuest Science Hour, a little bit short because we got started late today. If you'd like to join us for other activities, we have the Sunday night virtual star parties. We will be doing a variety of hangouts tailored to your part of the world this Saturday, no matter what time you're in, for International Observe the Moon Night. On Mondays, we record Astronomy Cast at noon Pacific, 3 p.m. Eastern, which is 8 p.m. London, and I no longer remember what time it is in Sydney.
Timeanddate.com.
Yes,
use the website.
timeanddate.com. Next week, if you return to the Science Hour, and we hope you will, it will be Emily Lakdawala hosting. And thank you, and go out and get involved in science. So talk to you later. Bye-bye.